Okay, so today what I'm going to do is go through some review problems for you to help you review for the exam. And I'm also going to show you a few things that you can use either with your exam or while you're working on your project. So first of all, while you're working on the exam, it should give you access to statcrunch the same way that you have while you're doing the MyStatLab homework problems, where you can click the box beside the data and have it directly go into statcrunch. Now, as far as I know, that will work while you're in your exam, but just in case it doesn't, I want to show you another way that you can use statcrunch in your exam. So for example, if you're taking your test and you have some data that you want to copy and paste into statcrunch and the website won't let you do it, you can always open up another browser and you can go directly to the statcrunch website. So here's how you would do that. If you just open up another browser, you can go directly to the statcrunch website by typing in the address statcrunch.com. Now this should take you to a page that has you sign in. To sign in, you'd use the same login ID that you used to sign into Blackboard. I'm already signed in, so it took me directly to this page. Now, if you're worried about being able to use statcrunch during your exam, I would test this out ahead of time and make sure that you can go to this website and make sure that you know the right login ID and password to sign into statcrunch outside of the MyStatLab program. So if you get to this page and sign into statcrunch, then if you want to copy and paste some data into the statcrunch data editor, then you just open statcrunch like this, and you can either copy and paste the data if you have column headings. You can put your cursor up there and then just do a right click and paste, or do a Control V to paste, just like you did with your Tiger data. You can also do it this way. So if you click on data and then load, if you have copied something to your clipboard, sometimes you have to do it this way. So if you do load and then you say from paste, then it will take whatever you had from your clipboard and it will let you paste it into this box. So if I had something copied on my clipboard, I could paste it in here. And then it has some questions down here about what the data looks like. So, and most likely if you're copying it from MyStatLab, it's going to be the delimiter of tab. So you don't have to change that. And then just fill that in and then go down here and click on load data, and it should put the data back into your statcrunch data editor here. Now, I do expect you to use statcrunch for some of the problems on the exam. There are some other ones where you could also use your graphing calculator. So if you have questions about using either one of those, make sure that you ask and get some help from me before you start your exam. Once you start your exam, I won't be able to help you with it. Okay, so let's look at some review problems that I have. So here's some sample questions. This first one is talking about identifying the data type of some different kinds of data. So in this one, it's talking about either qualitative or quantitative. Remember that qualitative is the same thing as categorical. Okay, so for part A here, if we're talking about the elevations of certain cities, that's going to be a quantitative variable because it's a number. And in fact, the elevation, if it were actually measured, it could be any value. It wouldn't have to be rounded to the nearest foot. It would actually be whatever the actual elevation of the city is. So it would not only be quantitative, it would also be continuous. I'm going to change this so I can write the answers on here. So this one is quantitative and it's continuous. The next one here, we're talking about the gender of survey respondents. That is a categorical or a qualitative variable. And the number of fish caught by each team in a fishing tournament. This one is also talking about a numerical measure, so this is quantitative. But since it's answering the question how many fish were caught, that means that it's a discrete value. So continuous is usually something that's a measured value. Discrete is something that's countable. So it means it answers the question how many. This one, we're at the same fishing tournament apparently, and we're talking about the weights of the fish. So again, this would be something that would be a measurement. So this would be quantitative, but it would also be continuous. Social Security numbers, although those are numbers, the numbers don't actually represent anything, so we can't take two Social Security numbers and add them together and get a number that means anything. So these are actually qualitative data. Okay, we're going to leave that last one alone. Okay, let's look at number 2. So in this one, a survey was conducted among 2,000 adult citizens in the United States, and it gives a statistic. So the question is, first of all, what population would be represented by this survey? So what you want to do here is look at the characteristics of the survey respondents. They were adult citizens in the United States. So that's the population that would be represented. So it has to have something with all the same characteristics as the people who are represented in the survey. Okay, and then for the sample, this is the people who were actually surveyed. Notice that the 56% doesn't have anything to do with that. That's just a statistic from the sample. So the actual sample is the 2,000 people that were surveyed. Okay, let's look at number 3. In this one, we have a study that was done, and we have the results shown. And it tells us about the study. So it says some subjects were intentionally afflicted with athlete's foot on both feet. One foot was treated with a fungicide, and the other was treated with a placebo. And then it's asking whether this was an observational study or designed experiment. In this one, because they actually applied 2 different treatments, so they were trying to affect whether the foot was cured or not, that means that this would be a designed experiment. Look at number 4. We've got the scores for 12 students on a math test, and it's asking us to construct a frequency distribution. So for this one, the important part is to get the classes right. So it tells you to start with a lower class limit of 65 and use a class width of 7. So if you're thinking about what your classes are going to look like, the first one is going to start at 65. Then to get the lower limit for the next class, you add 7 to this value. So 65 plus 7 would be 72. And then to get the rest of the lower limits, you just keep adding 7. 86, 93. Okay, then to get the upper class limits, since these are whole number values, for each one of these we want to go one below what the lower class limit for the next class was. So this first class is going to go from 65 to 71. This one would go from 72 to 78, and so on. We could fill in the rest of these that way. Okay, and then to get the actual frequency distribution, you would just go through for each of these and mark which class it's in, and so you would have the total number that are in this class, and so on. And we're going to do a couple of different things with this problem. One thing that we'll do is actually create a relative frequency distribution out of this. And this isn't what it says to do in the problem, but I'm trying to make up problems that are more like what you'll get on your test. So I'm going to put another column in here and do the relative frequencies. Okay, so to do relative frequencies, you need to have the frequency for each class, and for each frequency, you divide that by the total number of data values that are in the distribution. So in this one up here, it tells you that this was for 395 students. So we take each one of these numbers and divide it by 395, and that would give us our relative frequencies. Okay, so 16 divided by 395 is 0.168. So that would be our relative frequency. If we wanted to write that as a percentage, we could make it 16.8%, depending on what the question is asking you for. So same thing for the next one. We take the 53 and divide it by 395. That would give us our relative frequency of oops. Okay, I just realized on this one, I missed a button on my calculator, so that didn't come out right. Okay, so this one is actually 0.041. Okay, this one comes out to be 0.134. So that would be the same as 13.4%. To get the entire relative frequency distribution, we would just keep doing the same thing. We divide each one of these by our total of 395. Now, another question this one asks is about the shape of the distribution. And we talked about distributions being bell-shaped. That means that they're approximately symmetric on each side of the middle, and that the highest frequency class is basically in the middle of the frequency distribution. Skewed left means that the tail on the left is longer and that there's more of the data on the right side. Skewed right means that the right tail is longer and there's more of the data on the left side. So looking at this one, we actually our highest frequency class is not the one in the middle, it's this one from 24 to 31. So that's telling us that we would have more of our data on the right end of our distribution. So if we drew this out on a number line, this would be more towards the right end because these are the bigger class values. So since we have more of our data on the right end and we have some lower numbers on the left end of this, that would mean that this would be skewed to the left. Okay, let's look at number 8. So in this one, if you get a problem like this on the exam, it will give you the opportunity to copy the data into statcrunch. If I were going to do this from here, I would just have to type the numbers in. Now you can also do this on your calculator by putting the numbers in a list and then using the 1-bar stats. So once I have all the numbers in there, then it's asking me to find the mean and the standard deviation. So the easy way to do this in statcrunch is to do your summary stats. So it's the stat button and then summary stats and then columns. I didn't name my column, so it's still just var 1. And then if I just leave this, it's going to give me all of the basic information. It's already going to give me the mean and standard deviation. So I'm just going to click compute at the bottom. Okay, so here's my mean. Here's my standard deviation. In this problem, it's also asking for lots of other information. So it's asking for the quartiles. So in this one, we have the Q1 and the Q3. So there's my first quartile is 1405. My third quartile is 6719. My median is 3,689. So I could do my whole 5-number summary. I've got the min, the Q1, the median, the Q3, and the max, all of them included in here. The other thing that we talked about doing was the coefficient of variation. You need to know how to do that one. That isn't going to show up on your basic list of statistics, although you can get it if you tell statcrunch to give it to you. But if you have the standard deviation and the mean, it's really easy to figure out the coefficient of variation. You just take the standard deviation and divide by the mean. So I'm going to put an extra line in here about the coefficient of variation. So that's the standard deviation divided by the mean. So in this one, that would be 2,656.7 divided by 3850.9. Okay, so what that gives me on my calculator is 0.68. Actually, it's 0.69 if I round it. The coefficient of variation we usually put in percentages, so this would be the same as 69%. So if we have basically a bell-shaped distribution with a mean of 98.2 degrees and a standard deviation of 0.62 degrees, if we're trying to find the z-score for a body temperature of 99.7 degrees, the value that you're given, the data value that you're given, is the x in the z-score formula. So, and remember, the formula looks something like this. It's x minus the mean, and then that's divided by the standard deviation. So this would be our data value, which is the 99.7, minus our mean of 98.20. That's divided by the 0.62. And it's really important on these that you do this in the right order. That's why I put the parentheses in here. If you put it in your calculator like this, but you don't put the parentheses in, it's actually going to give you the wrong answer. So the idea here is that you have to take the 99.7 minus the 98.2 first, and then divide that answer by the 0.62. So for this one, you should come out with approximately 2.42. Okay, we would do the same thing for part B. This one, because our value is actually below the mean, this is going to come out with a negative z-score. So we would use the same formula, but for this one, we should come out with a negative number. Okay, then on part C, we're talking about the empirical rule. Remember that had the values for the middle 68%, the middle 99, or the middle 95%, and the middle 99.7%. That depended on how many standard deviations above and below the mean you were. So if it's the middle 68%, that means you're going one standard deviation below the mean and one standard deviation above the mean. So if we take our mean and subtract one standard deviation, so if we subtract 0.62, that's going to give us the cutoff value for the lower part. So that's going to give us 97.58. And then for our upper cutoff value, we're going to take our mean and add had 1 standard deviation. So that gives us 98.82. So our 2 cutoff values would be the 97.58 and the 98.92. So the middle 68% of the body temperatures would be between those 2 values. Okay, and then if we wanted to figure out part D, what percentage would be between these 2 values, we'd want to figure out how many standard deviations those were either above or below the mean. Okay, then let's look at number 12. If you have a question that asks you about something like this, about 2 different tests with 2 different means and standard deviations, and it asks you which score is relatively higher, what you're looking for is the one with the greater z-score. So you would figure out the z-score for each one of these test scores and then compare the 2 z-scores to find the answer for this. So for this first test, this test had a mean of 6 and a standard deviation of 1.2. So for that one, we would take our actual test score, which was the 4, subtract our mean, and then divide by the standard deviation, and that would give us our z-score. Okay, so this is coming out to be negative 1.767 approximately. And that one is negative again because our test score was lower than the mean. So that was for the first one. For the second test, our score is 300. Our mean was 376. Standard deviation is 42. So if we calculate that, we get a negative 1.81 approximately. So now we're looking for which one has the greater z-score. Since these are both negative numbers, actually the negative 1.67 is the larger of those 2 numbers. It would be further to the right on the number line. So this means that this is the one that has the higher z-score. So the score of 4.0 on this test is actually relatively higher than the score of 300 on this other test. And this is talking about a survey. And first of all, you're looking at what population would be represented by this survey. The key in this one is that the researcher had 10 popular magazines include the survey in their June issue, and then the responses could only be entered by visiting a website. So this would be what we call a voluntary response survey, and that means that it can only represent the people that actually responded to it. So the population represented would be only the people that responded to the survey. And again, that's because this was a voluntary response survey, and that means it's not going to be representative of a larger population. Okay, and that's part of the answer to part B of what's wrong with the researcher's sampling method. He was missing lots of data because the only people that would get this would be the people that bought the magazine's June issue, and probably those that had strong opinions on the question, because they would be more likely to respond since it's a voluntary response survey. The other thing that is wrong with this is that if you read the question they were asked, this is a very loaded question. Where it's talking about restricting the ability of Americans to protect their families, that's a very emotionally loaded way to say that. So if you wanted, that would tend to suggest to people a particular answer. So if you wanted to eliminate bias, you would need to rewrite the question so that it's not emotionally loaded. Okay, let's look at this one with the histogram. So this is a basic thing about interpreting a histogram. So looking at this one, we've got the selling prices for homes sold in 2008, and we've just got a relative frequency distribution shown on our histogram. So first it asks us for the class with the highest frequency. So that would be this one that has the highest bar. And the class, if you look at where these bars are going, we've got 2 bars between 200,000 and 300,000. So that means that the second class would be starting at 250,000. And the third class actually starts at 300,000. So this second class would actually be going from 250,000 to 299,999. It can't actually go all the way up to the 300,000 because we can't have the classes overlapping. The class with the lowest frequency would be this one on the end. So again, that would start at 500,000 and it would go up to 549,999. You could approximate the percentage of homes that were sold for more than 400,000. So that would be these 3 bars here. So we would want to approximate the percentages for each one of those 3 bars and add them together. Then for the class width, again, you're looking at how far it is from the beginning of one class to the beginning of the next class. So that we kind of already figured out that these were going up by 50,000 each time. So our class width would be 50,000. And then this one, looking at the distribution shape, this one would probably be skewed to the right because we do have more of the data on the left side. It's definitely not symmetric, so it couldn't be bell-shaped. But for this one, since we do have more of the data on the left side, that means it would probably be skewed to the right. And one thing you might be asked to do on the test is to take a stem and leaf plot like this and say what some of the data values are. So for instance, in this one it tells you that the stem width is actually $10,000. So that means that the 1 here represents $10,000 and each digit over here represents 1 data value, and that would be what's happening in the next place. So this first, the lowest data value in here would actually be 16,000. So our lowest data value would be 16,000. And our highest data value down here, again, this 4 would signify 40,000, and then these digits would be in the thousands, so that our highest data value would be 46,000. And then again, we could look at this one to look at the shape of the distribution. Since this one has more data values at the top, if we kind of turn this on its side and looked at it like a histogram, that would mean we'd have more data values on the left and we'd have a longer tail on the right. So this distribution would be skewed to the right. Looking at these two graphs, we want to look and see if there's anything that might be misleading about these two. One thing that you can see if you look at this pretty closely is that the vertical scales are different. So the way this looks, it makes it look like the incomes for males and females are just about the same. But if you look at the scales, they actually aren't anything near the same, because the scale for this one is 30,000. That means that this last bar in the year 2000, the median income is something like 27,000. Whereas for the females, since that highest value there is 18,000, this would only be probably 17,000. So we've got 27,000 versus 17,000. So they're really not the same at all. So that would be the big thing that would be misleading for these graphs, is that they use different vertical scales. This is talking about blood pressure and gender. So let's look at question B. So if one of the subjects here is randomly selected, find the probability that the person is female or had a low blood pressure reading. The or signals that we're talking about using the addition rule. The addition rule says that to find the probabilities of A or B, you can add the two probabilities, but you have to make sure that nothing gets counted twice. So what we could do in this is just look at the cells that would be either people who were females or who had low blood pressure. So the low blood pressure would be this one and this one. And then the females are this one, and this one. So if we did it this way and just mark the cells that would be one or the other of these, then we could just add up those numbers. So we could take 12 plus 17 plus 92 plus 19, add those together, and then to get the probability, we would divide that by 236. Okay, so that's 140. And then to get our probability, we take the 140 divided by 236, and that would give us our answer. Now, the other way we could do this is to just add the totals. So we could take this total for the low blood pressure, and we could take the total for the females. Now, if we add those two together, we're actually adding in this set of females twice. So that would mean that we'd be taking this one and adding it in there twice, so we'd have to subtract it back out. So we could do it that way, or we could also take the 29 plus the 128, and then we'd have to subtract the 17 because we actually added it in there twice. So that should give us the same answer we got here, which was 140. And then again, to get our probability, we divide the 140 by the 236. So for this one, we're just looking at how many marbles would be in this event. So since there were 8 red marbles, that's how many would be in the event of getting a red marble. We want to take that and divide by the total in the sample space. So our sample space is the 8 plus the 10 plus the 2, which is 20. So our probability is just going to be 8 over 20 which would be 0.4 or 40%. Another question we could ask here would be, what's the probability that marble we selected is not red? So since we already know the probability that a randomly selected marble is red, this would be the complement. So the naught tells you that it's the complement. So that's the important part of this. To get the probability for the complement, we could just take the probability for our original event and subtract that from 1. So we could take the 1 minus the 0.4, and that would give us the probability for this one. So the probability that it is red is 0.4. The probability that it's not red is 0.6.